All right, welcome back, you guys. We're going to take a look at graphs of the other trig functions. So tangent, cotangent, cosecant, secant. We're going to start out with the cosecant function. So the cosecant, we know that's the reciprocal function. So that's the same as 1 over the sine, right? So if I was thinking about where's this thing undefined, well, I can't divide by 0. So I would have vertical asymptotes anywhere where the sine is 0, right? So if I'm thinking about my unit circle, where's the sine 0? Well, I know the sine is 0, y value 0 is a 0, or if I rotate pi, I know the sine value there is also 0, so 0, pi, 2 pi, this keeps going, right? I could also go in the negative direction. Negative pi has a sign that's 0, so these are plus minus. And so that's where my vertical asymptotes are. X equaling 0, so it's not going to touch that dotted line. X equaling pi, there's another vertical asymptote. X equaling 2 pi, and so on. And that's where you're going to have your vertical asymptotes. And then from there, what you do with the cosecant is you can plot a few points. Okay? And so, let's make sure wondering if okay. I hope I didn't upload my red notes here. So let's plot a few points. Let me erase this for just a second. Let's plot a few points to the right of 0. So let's go with like pi 6, pi 4. So some nice points on my unit circle that I can plug in. Pi halves. We keep going. 2 pi thirds. 3 pi fourths, 5 pi 6. I don't want to plug in pi because that's where my vertical asymptote is, nor do I want to plug in 0. But let's go ahead and plug those ones in. So we got y equals cosecant. Let's plug in the pi 6. Cosecant of pi 6. Well, that's 1 over the sine of pi 6. So I find the y value at pi 6. The y value there is 1/2. So 1 over 1/2, flip it over, right? 2 over 1, top and bottom. So we got y equals 2. So we got pi 6. Pi 6 is about right here. Pi 6, comma 2. Right, and I put that point on there. Then I plug in pi 4. So we got cosecant pi 4. That's 1 over the sine of pi 4. So that's 1 over root 2 over 2, which is 2 over root 2. Rationalize that. So I got 2 root 2 over 2, which is just root 2. Well, root 2 is about 1.414. So pi 4 spits out 1.414, and I put that dot on. I plug in pi thirds, so I'd have 1 over root 3 over 2, so that'd be 2 root 3 over 3. Or 1.155. That's at pi thirds. I put that dot on there. Then I plug in pi halves. So I got 1 over the sine of pi halves. Well, the sine of pi halves is 1. So I got 1 over 1. There's the 0.1 pi halves comma 1. Then I keep going with this, right? I punch in 2 pi thirds. And I'd get that 2 root 3 over 3, which is 1.155. There it is at 2 pi thirds. And I'd plug in the 3 pi fourths, and I'd get the root 2, and then I'd punch in 5 pi 6, so 1 over sine of 5 pi 6. Well, the sine of 5 pi 6 is 1/2, so I got 1 over 1/2, which is 2, and so on. Right, 5 pi 6 is 3 pi 4. Anyways, you get enough of these, you start seeing, oh, and I can connect these dots. I can draw that part of my cosecant function. And I'd do the same thing over here. I'd punch in 3 pi halves, and I'd get the negative 2, and I'd punch in a few more points, as many points as I needed to start drawing that thing. And I could draw that thing. Let me kind of erase some of this other for a minute. And this is showing you one period. So it takes 2 pi to repeat this. So if you were to draw the rest of this graph over here, what you're going to see is the same thing repeated over here. Okay. And so that's the cosecant function. Now, so what's that dotted green line in there? Well, if you were to graph, you know, the cosecant's the reciprocal of the sine. If you were to graph the sine, you see it in green there. See how it touches the minimum right there? The max of the sine is the minimum on that portion, at least, of the cosecant. And then over here, they touch. And if you notice, the 0 of the sine function is where you have that vertical asymptote, right? Since that's where the sine is 0, right? Because the cosecant's 1 over the sine, so that'll make that thing undefined. That's why you got a vertical asymptote there. So that's the cosecant function. So let's look at the secant function. So if you're graphing the secant function, again, you'd say, well, that's 1 over cosine. My vertical asymptotes would be wherever this cosine is 0. Well, I know the cosine of pi halves is 0. So I draw pi halves. That's the vertical asymptote. I also know cosine negative pi halves is 0. So this is plus or minus. I also know the cosine of 3 pi halves is 0, as well as negative, and so on. So there's x being negative pi halves. There's x being 3 pi halves. And you could plot in green. The cosine is in green. And cosine 0 is 1. Cosine pi halves 0, and so on. Right, there's the green cosine. And that can kind of help you to draw this secant. Right, but you could plot a bunch of points as well. This period is also 2 pi distance from negative pi halves up to 3 pi halves. Okay? And so what we'll do is we'll kind of use those as our parent functions today to go through this. Okay? All right, so let's go on this first one too, the secant of x over 3. The first thing, so I'm thinking about my secant graph, but number one, if I was to pretend this was the cosine function for a minute, then my period would be 2 pi over b, right? And can you see how I have 2 secant? My b here is 1/3 x over 3. So my period here is 2 pi over 1/3. Well, flip that over, 3 over 1, 3 over 1, top and bottom, I got 6 pi. So my period is 6 pi. So this is a horizontal stretch. Okay, so it'll take us up to 6 pi to do that. And then, again, pretending like if this was the cosine function, what would our phase shift be? And our phase shift here is c over b. Well, the c is 0, right? So I got 0 over 1/3. So the phase shift is 0. And so we'll go ahead and start there. And then we'll find the increment. In other words, how much do we go up from that by? Let's find the increment here. So the increment is 1/4 of the period, similar to last time. So 1/4, our period here is 6 pi. So our increment is 6 pi over 4. So 3 pi over 2, 6 pi over 4 is our increment. So when we're plugging in points, we're going to go ahead and start at our phase shift point. And this will actually be where a nice value for us. And then we'll go up our increment each time. So 0 plus 3 pi over 2 is 3 pi over 2. And then I'll go up another increment from 3 pi over 2. So 3 pi over 2 plus another increment 6 pi over 2, which is 3 pi. And then I'll go up another increment from there. So 6 pi over 2 plus 3 pi over 2, 9 pi over 2. And then 9 pi over 2 plus 3 pi over 2 is 12 pi over 2. Well, that's 6 pi. And that's our last point, okay, that we'll plug in. And now you can just plug them in one by one. So we got 2 secant of 0 over 3. So 2 secant of 0. Well, secant's 1 over cosine. And so we know the cosine of 0 is 1. So we got 2 times 1 is 2. 0, 2. Now you do the next one. 2 secant. Now I'm going to plug in the 3 pi halves. So I got 1/3 x. 3 pi halves is the x. So notice I got pi over 2. I got 2 secant pi over 2. Well, the secant's 1 over the cosine. Well, remember, the cosine of pi halves is 0. I can't do this. No, that's because that's where my vertical asymptote is. This is not defined there. Okay. I'll throw in 3 pi. Let's do a couple more here. 2 secant of 1/3 times 3 pi. So I got 2 secant of pi. Well, that's 2 times 1 over cosine of pi. Well, the cosine of pi is -1. So I got 2 times -1 is -2. I'll throw in 9 pi over 2. That'll be undefined again. I'll plug in 6 pi and I'm going to get 2. Let's go ahead and graph this thing. Got a vertical asymptote. So I'm going to start at 0, 2. Let me put that on first. And then I'm going up by 3 pi over 2. And 3 pi over 2, it's undefined because we got the vertical asymptote there. And then we got another nice point up 3 pi over 2 plus 3 pi over 2, 6 pi over 2, which is our 3 pi. That gave us -2. And we're going up to 9 pi over 2. That also had a vertical asymptote. And then the next one is 6 pi, which gives us a 2. Okay, and think again to yourself, this is 2, so kind of the 2 in front vertically stretch it. And then the period is 6 pi. It takes 6 pi to do one of these periods. Let me show you the secant again. So I'm thinking up here, I'm looking at this one here, right? And if you're not sure, you can also graph, if this was cosine, you could graph the cosine of x, 2 cosine x over 3, and what you'd see is it touching it like that, and that kind of helps you draw the secant. Shape on that. Of course, you could go over here. That's -3 pi over 2, and so on. But hopefully you see that total distance here is 6 pi. It repeats that, right? It repeats that every 6 pi mile, or if you want to think about it right there, 6 pi to do that, 6 pi to do that. Right? That's your period on that. Let's do another cosecant. So here we got a -3. So this will flip, it'll reflect it about the x-axis, and that minus pi force, that's going to shift it. It's going to shift it a little bit. Okay, so our fascia's got a little movement to the right there of pi force. Okay, so if you're thinking to yourself, -3 cosecant, so it looks like this one, but it's going to flip it over about the x-axis, and then it's going to shift it over. Okay, that's what's going on this. Let's see if I can erase that. Maybe, maybe not. So again, pretend it's the sine function for a minute, right? And so your period would be 2 pi over b. B is the number in front of x there. So we got 2 pi over 1. So our period is 2 pi. Our phase shift, Ex minus c is c. Phase shift is c over b. So we got pi force. There's our phase shift, minus c. So minus pi force all over that b, which is 1. So we got pi force over 1 is pi fourths. So we'll start at pi fourths on this. And number 3, our increment, which is again 1/4 of our period. So we got a fourth of our period, which our period is 2 pi. So 2 pi over 4, which is pi over 2, is our increment. And so you can plug these points in starting at the phase shift. So starting at pi fourths. And with the cosecant function, this will actually get, that first one will actually give us our vertical asymptote. And so then we'll go up incrementally, up pi halves from there. Well, that's the same as pi over 4 plus 2 pi over 4. So 3 pi over 4. Here's the next one. We punch in 3 pi over 4 plus another 2 pi over 4. It's 5 pi over 4. 5 pi over 4 plus another 2 pi over 4. 7 pi over 4 plus another 2 pi over 4 is 9 pi over 4. And this will give us some nice good spots. Let's go ahead and plug a few in. Let's plug in the pi force. Pi force minus pi force is 0. So I got -3. Cosecant of 0 is 1 over the sine as 0. But I know the sine, the y value at 0 is 0. I can't do this. Why? We got that vertical asymptote. Anywhere where it's undefined, we're going to have that vertical asymptote. So we'll have a vertical asymptote there. Same thing if we plugged in 5 pi force. 5 pi force minus pi force. Let me punch this one in. 5 pi force minus pi force is a pi. 4 pi over 4 is just pi. And we know the sine of pi is 0. So again, that's also going to be a vertical asymptote. That one will also be a vertical asymptote. And then we want to punch in, now let's punch in 3 pi over 4. 3 pi over 4 minus pi over 4 is 2 pi over 4, or pi halves. So we got -3, 1 over sine of pi halves. Well, the sine of pi halves is 1, so I got -3 here. Punch in 7 pi force, so it'll spit out a 3, and so on. And then we can graph, get a little bit of a feel for this. So at pi force, I've got vertical asymptote, and I'm going up pi halves from there every time. So 3 pi force, 5 pi force has another vertical asymptote, pi force, 9 pi force has another vertical asymptote. At 3 pi force is -3. And remember, it flipped this over, so this is going to go this way now, the first one. Right, because it's flipped it instead of being up here. Right? I flipped it all over with the -3 in front of the cosecant. Reflection about the x-axis. 7 pi force, I've got 3, right? And so I can kind of draw that. If you need more points, you can throw some more points on there. If you were to graph -3 sine of x minus pi fourths, then you'd have, let's see, then coming down, it'd be like this kind of deal, right? So, anyways. All right, let's keep going here with a secant. So secant, again, I'm thinking about the cosine function. Similarly, if I pretend I have this cosine function, let's go ahead and find our 2 pi over b. You see how our b here is that 2 pi. So we got 2 pi over 2 pi. So our period here is 1. Our phase shift, this is negative 1/3 secant 2 pi x minus 0, right? There's our c, bx minus c. Phase shift is c over b, so I got 0 over that 2 pi. So I got 0 for my phase shift, so I'll start there. Increment is 1/4 of my period. So in this case, 1/4, my period is just 1. So it's incrementally going up by 1/4. So when I'm plotting points, I'm going to start at my phase shift, and I'm going to go up 1/4 from there. So 0 plus 1/4, 1/4. 1/4 plus 1/4, 2/4. 2/4 plus another 1/4, 3/4. 3/4 plus another 1/4 is 4/4, or 1. Those are my nice points that will be very helpful in plotting, and now I can plug them in. Let's plug in the 0. So we get 2 pi times 0. So I got secant of 0. Well, secant is 1 over cosine. So cosine of 0 is 1. So I got negative 1/3 times 1, negative 1/3. So there's my first point. Let's throw in the next point. So I got 2 pi over 4, or pi over 2. So I got negative 1/3 times 1 over cosine pi over 2. Remember, the cosine of pi over 2 is 0. I cannot divide by 0. Can't do this. So I have a vertical asymptote right there. That's where my vertical asymptote is. And I do the same thing. I could plug in 1/2. It's going to spit out a positive 1/3. Plug in 3/4. It's going to be undefined again. I plug in 1. I get the negative 1/3. Right? And it looks like, so this looks like my secant function, but it's flipped it over because it's negative 1/3. And it's vertically compressed. And then my period, instead of being the 2 pi, my period is 1. So there's a horizontal compression because 2 pi is bigger than 1. So let's go ahead and graph all this. So 0, negative 1/3. 1/4, I've got the vertical asymptote. 1/2, I've got third. 3/4, I've got another vertical asymptote. 1, back down here to negative 1/3. Right? And we could plot some other points. I could also put on here, what does negative 1/3 cosine 2 pi x look like? And it would show you that. That may be helpful as far as graphing this thing. So it would go the other direction like that, right? Anyways. Let's talk about the domain and range here on this one. So if you notice the domain, everything's involved except where you have these, like it takes in all these x's except where you have these vertical asymptotes, right? So you got a vertical asymptote, you got a break here at all those spots. So for this, one way to solve that, let me write it this way, negative 1/3, 1 over cosine 2 pi x. So I've got negative 1 over 3 cosine of 2 pi x. And so where is this undefined? That's where our vertical asymptotes, that'll tell us where the domain is. The domain will be everywhere except where that thing is undefined. I need some more room here. Let me come over here. So where is 3 cosine 2 pi x? Where's that equal 0, right? Well, if I divide by 3 both sides, I'll get rid of that. Whereas cosine 2 pi x equals 0. Well, we know cosine of pi halves, for example, is 0, right? And then the cosine of 3 pi halves is 0. And the cosine of 5 pi halves and so on. So let me do it in general form. The cosine of pi halves plus n pi is 0. And that'll tell you where this thing is undefined when you set this equal to that. That'll give you all places. N is an integer, right? So like this pi halves, for example, pi halves plus 1 pi if n is 1. Or let's do 0 first. Pi halves plus 0 pi. We know the cosine pi halves is 0, right? If n is 1, cosine of pi halves plus pi, that's 3 pi halves. We know the cosine of 3 pi halves is 0. If n is 2, now I got the cosine of 5 pi halves and so on. So it gives me every one of those spots where the vertical asymptote is. So then we just got to set it equal to, where's 2 pi x equal pi halves plus n pi. And so we got to divide everybody by 2 pi. Divide that by 2 pi, that by 2 pi, that by 2 pi. And so we have pi, oh, the pi's cancel, I'm sorry. We got, I'm going to mess with this. Got 1/4 plus n over 2, where n is an integer. Or if you want to make this as 1 plus 2n all over 4. So the domain is all reals except for anywhere where x is 1 plus 2n over 4, where n is an integer. That's a bit much. I'll do this with the tangent here in just a second, make a little more sense of it. But what it's saying is the domain's everything except where these vertical asymptotes are. That's just the general form of that thing. And then the range is coming from negative infinity up to, in that case, negative 1/3, all right? The range is negative infinity up to negative 1/3. I do hit it. And then there's a break. There's nothing in between y value-wise. But then I keep going from 1/3 up. Right? It does hit all these up, right? From a y value 1/3 up. But all right, let's get into the tangent. So how do I build the tangent here? Let me give myself a little room. Tangent we know is sine over cosine, right? So I'm first going to talk about, well, where is this thing undefined? Well, I can't divide by 0, so anywhere where this is true, right? And again, we know cosine of pi halves is 0, so x being pi halves satisfies that. We know cosine of 3 pi halves is, we know cosine of 5 pi halves, and so on, right? So to generalize that, if I just add n pi, where n is any integer, this will be true. And so all our vertical asymptotes will be at pi halves plus n pi. Again, n is an integer, right? So integers meaning counting numbers, 0 and the negatives, right? That'll take care of all of them. So for example, if n is 0, I have pi halves plus 0, so x being pi halves. There's our first vertical asymptote where the tangent's undefined. If n is 1, I got pi halves plus pi, so pi halves plus 2 over 2. 2 pi over 2 is 3 pi over 2. There's our next one. If n is negative 1, I got pi halves minus pi. That's negative pi halves. And so my domain, if I want to write the domain of my tangent, my domain is all real numbers except for pi halves plus n pi, where n is an integer. All right. Or if you get a common denominator, that would be 2n plus 1 pi all over 2, like I wrote right there. Another way to write that, same thing. Okay. So that's where you're going to have vertical asymptotes. That's where your domain is everything but those x values. So now, how about plugging some points in now? So let me erase this and let's get into the points. And let's plug some points in. So let's go between negative pi halves and pi halves. Let's plug in like pi 6 first, then we'll plug in pi 4ths, then we'll plug in pi 3rds. Of course, we can't plug in pi halves, but let's go ahead. And 0, we'll do 0 as well. So 0, pi 6, pi 4ths, pi 3rds. Can't plug in pi halves because I have a vertical asymptote there. And let's plug them in. We know the tangent of 0 is the sine at 0 over the cosine at 0. Well, we know the sine of 0 is 0. We know the cosine of 0 is 1. So 0 over 1 is 0. So we have the point 0, 0. There's our first one. Now let's plug in pi 6. So sine of pi 6 over cosine of pi 6. Cosine of pi 6. We know the sine of pi 6 is a half. Cosine of pi 6 is root 3 over 2. So I got 1 over root 3. Or root 3 over 3. And then if I punch in like root 3 over 3, let's see, get 7. Now I'm going to throw in pi 4ths. And the pi 4ths one's really nice because I know the sine of pi 4ths is the same thing as the cosine of pi 4ths. Cosine of pi 4ths. Also root 2 over 2. So that gives me 1. So pi 4ths is nice. It's right there at 1. Pi 6 is at 0.577. Punch in pi 3rds, and I get sine of pi 3rds is root 3 over 2. Cosine pi 3rds is 1/2. And so I got root 3 over 1, which is about... So I put that one on there. Anyways, I could plug in a bunch of more points. I could go negative pi 6. I could go negative pi 4ths. I could go negative pi 3rds. And soon I would see this curvature. There's my tangent function. And then I'd plug in pi. And I'd plug in like 5 pi 4ths is another good one because it gives me the pi. I'd plug in like 3 pi 4ths would give me the negative 1. Anyways, graph, and you start seeing this tangent function, and its period of the tangent's only pi. It only takes pi distance to repeat that. See how it repeats it again there? Same thing, and it's increasing. Okay, so that's the tangent function. The cotangent's defined as cosine over sine. So now you're looking for where is the sine equals 0, right? And we know the sine of 0 is 0. We know sine of pi is 0. That's where we're going to have our vertical asymptote, sine of 2 pi, and so on, right? Because we know the sine of n pi, where n is an integer, is 0. So all the vertical asymptotes will it be at n pi, where n is an integer. That'll give us all the vertical asymptotes for the cotangent function. And then same thing, we plug in some points. I could plug in pi 4, so I get 1. I could plug in 3 pi 4, so I get negative 1. And this one is actually decreasing. There's our cotangent function. Okay. And that brings us to the general forms of the tangent and the cotangent. So its period, and notice here, also the period here is pi. Right? And no amplitudes on these functions that we're dealing with today, you guys. There's no amplitudes on these because we don't have a high and a low value. Remember, the amplitude was the highest minus the lowest divided by 2 from the sines and the cosines. All right, so here's our general form, a tangent bx over c. So the first thing we're going to do is we're going to find our period with this. And then the second thing is I'm going to find my phase shift. And the third thing is I'm going to find what I'm referring to as the half point. Okay, and I'll tell you what we're going to do with that half point in just a second, because it depends on our tangent or our cotangent, where we go incrementally. That's our incremental movement for points, okay? Let's go ahead and do it with this first one. Let's just go ahead and identify a period. A tangent bx minus c, all right, plus d. So our period here is pi over b. So we got pi over, and you notice the b here is a half. Flip it, 2 over 1, 2 over 1. So we got 2 pi as our period. Our phase shift is c over b. Here our c is, think about this as 1/2 x minus a negative 1 pi thirds, right? There's our c. It's following the minus, right? Negative times a negative is a positive. So the c here is negative pi thirds over our b is the 1/2. So again, flip that. And we got negative 2 pi. Phase shift is negative 2 pi over 3. Do some more here. Period and phase shift for a cotangent similarly. So we got period as being pi over b. Here's our b, 3 pi over 4. So I got pi over 3 pi over 4. So times 4 over 3 pi. 4 over 3 pi. Let's see what we got. We got 4 pi over 3 pi. So we end up with 4/3 for our period. Our phase shift, bx minus c. So our c follows the minus there. C is pi 6. Our b is 3 pi 4ths. And so we got 4 pi over 18 pi. Pi's cancel. So it looks like we got 2/9 as our phase shift. Okay. And that'll bring us to, let's use that. And let's go ahead and graph a tangent. So this is the tangent function, but it's shifted to the left here, x plus pi 4. So it's going to shift that to the left. But we want to graph this over 2 periods. Okay. And so what we'll do is, number one, we'll go ahead and find our period. So a tangent bx minus c. So our period is pi over b. So in this case, our b is just that in front of the x there, pi over 1. So our period is pi. Our phase shift, c over b. So our phase shift is negative pi 4ths over 1. So negative pi 4ths, okay? And so what we'll do is, the third thing is we'll find what's called our half point. Okay? And so the half point is actually the period divided by 2. It's the period divided by 2. So in this case, our period is pi over 2. And what we'll do with the tangent is the first point is the phase shift minus the half point. Okay? So the first point, instead of starting at the phase shift, if you go phase shift, so our phase shift is negative pi 4ths, and then minus our half point, phase shift minus half point. And what this will do is it'll give you your first vertical asymptote. So negative pi 4ths minus 2 pi 4ths is negative 3 pi 4ths. Okay? Then my next point I want to be the phase shift. That's my next point. This will give me a solid, it'll give me my intercept. Okay. And then I'll go up incrementally. So phase shift plus half point. So negative pi fourths plus pi halves. So negative pi fourths plus 2 pi fourths is just a pi fourths. And then I'll go up another half point from there. So pi fourths plus another half point plus pi halves. 3 pi fourths. And then I'll go up another half point from there. So 3 pi fourths plus another pi halves. So 3 pi fourths plus 2 pi fourths. 5 pi fourths. And that's my last one. Okay. And so if you plug these in, I don't know that you'll have to plug them in every time, but we'll plug in on this one. So we got tangent. Let's throw in the negative 3 pi fourths. So negative 3 pi fourths plus pi fourths is negative 2 pi fourths or negative pi halves. So I got sine of negative pi halves over cosine of negative pi halves. So I've rotated here, right? So I'm at this point, negative pi halves. The sine there is negative 1, but the cosine there is 0. Oh, this is undefined. That's because that's my first vertical asymptote. The pi fourths, so if the negative pi fourths is going to give me the next intercept, but the pi fourths will give me another vertical asymptote. The 3 pi fourths will give me another intercept, and then the 5 pi fourths will give me a vertical asymptote. So let's throw in negative pi fourths now. So negative pi fourths plus pi fourths, I got tangent of 0. So sine of 0 over cosine of 0. Well, sine of 0 is 0, cosine of 0 is 1, so I got 0, 1 is 0. See how that works? And these are giving me some nice points. Same thing for the 3 pi fourths. So now I can kind of graph this thing. So negative 3 pi fourths, vertical asymptote, pi fourths was a vertical asymptote, and 5 pi fourths vertical asymptote. Let me plot that point. Negative pi fourths 0, 3 pi fourths 0. And it looks like the tangent function. So it's going to be increasing because I didn't flip it over the x-axis. I could put some more points in. So another really nice point to put in is right between negative pi fourths, right between here and here. Right, like to throw in 0. Right, let's split the two. Split it between the intercept and the vertical asymptote. So throw 0 in. That's a good midpoint. If I throw 0 in. Why is that? Because I know the tangent of pi fourths is sine of pi fourths over the cosine pi fourths. So it gives me the point 0, 1. Right, it gives me a nice point. So I know that thing is increasing. And I've showed a couple periods here, right? Here's a period that had a distance of pi. This had a distance of pi. It was the same curve there. Do this one with a 4 in front, so that's going to vertically stretch that. And then we got that pi thirds x, which will affect its period. So let's start going through this with the tangent function. So our period for the tangent pi over b, and b here is that pi thirds, right? So we got pi over pi thirds. And so we got 3 pi over pi, which is 3. There's our period. Our phase shift is c over b. So imagine a minus 0 in there. So our c is 0 over pi thirds, which is just 0. And then our half point, which will help us with the increments. Our half point is the period just cut in half. Well, our period here is the 3 over 2. And so with the tangent, Remember, the first point is actually not the phase shift. It's the phase shift minus the half point. That's where you want to start with the tangent. So 0 minus 3 halves is negative 3 halves. And that'll give you your first vertical asymptote for this one. And then you want to go to your phase shift, which is 0. And then you'll go up a half point, phase shift up half point. So 0 plus 3 halves is 3 halves. And we'll keep going up 3 halves. 3 halves plus 3 halves is 6 halves, or 3. 6 halves plus 3 halves is 9 halves. And there's all our points. We're going to have vertical asymptotes. If you plug those in, they're undefined there. We'll throw in, why don't we throw in, let's throw in the 3, but we could throw in 0 too. So y equals 4 tangent pi thirds times 3. So we got 4 tangent of 3 pi over 3, which is just a pi. Tangent pi is sine of pi, cosine of pi. Sine of pi is 0. Cosine of pi is negative 1. 4 times 0 is 0. So that gives us that point 0. We could throw in 0 and we'd also get 0. So we've got our vertical asymptotes and we've got some intercepts here. We can go ahead and draw this pretty decently. Here's negative 3 halves. It's got a vertical asymptote. Here's 1 1/2. Another vertical asymptote. There's 9 halves, another vertical asymptote, 0, 0. And notice this 4 in front, it's positive, right? So it's still going to increase. It'd be nice to throw in something between 0 and 3 halves. So what's between 0 and 3 halves? Like 3/4 is a great point to throw in. You can see where that hits. 4 tangent pi thirds times 3/4 for x. So we got 4 tangent pi fourths. Sine of pi fourths over cosine pi fourths. That's the same thing. So it's 1. Tangent pi fourths 1. So we got 4 times 1 is 4. So when I plug 3/4 in, I get 4. It gives us that. Again, that's called a middle point, right? But let's go ahead and plot 3, 0. And it's going to look similarly. I know this is not the best graph, but anyway, so on, right? You draw that for the tangent there. I do have another one. I think we've got enough time to do a tangent here. This time is reflected about the x-axis. Notice the negative 3, and then it's shifted. See that 3x minus pi half, so we've got a phase shift on this one. So let's go through it. Our period is pi over the b. Our b here is 3. So our period is pi over 3. Our phase shift is c over b. So the pi halves over the 3. So we got pi. 6 is our phase shift. Our half point is the period over 2. So pi thirds over 2. So that's pi 6 is actually our half point. And remember with the tangent, we're going to take the phase shift minus the half point. So in this case, I actually want to start at 0, and that'll give me a nice vertical asymptote right there. If I plug it in, you'll see that's undefined. And then I go with my phase shift, pi 6. And then I'll go up from there the half point. In this case, the half point's pi 6 as well. So pi 6 plus pi 6 is 2 pi 6, or pi thirds. And then I'll go up 2 pi 6 plus another half point. Pi 6 is 3 pi 6, or pi halves. I'll go 3 pi 6 plus another pi 6 is 4 pi 6, or 2 pi thirds. And that'll be my last one. So that'll be a vertical asymptote. That'll be a vertical asymptote. These will give me my intercepts here. If I plug those points in, x equaling 0. This is at pi 6 this time. Pi thirds is another vertical asymptote. And this will flip it over, right? I got a negative in front, so it'll flip it. Instead of increasing, this will be decreasing. And a great point to plug in would be between, let's go between pi 6 and pi thirds, right? So what's between pi 6? Let me do it this way. What's between 2 pi 12ths and 4 pi 12ths, which is pi thirds? So that would be 3 pi 12ths. In other words, pi fourths would be a great one to plug in. So I got y equals negative 3 tangent 3 times 3 pi 12ths or pi fourths minus pi halves. So we got 3 pi fourths minus 2 pi fourths is a pi fourths. I know the tangent of pi fourths is 1. And that gives me the negative 3. That's that point. Pi fourths comma negative 3. Again, that's just a middle point if you want to make sure that you have that graph going the right direction on the tangent. All right, let's get through one of these cotangents here, or a few of these cotangents. We'll start out with the cotangent. The only difference is we'll start back again at the phase shift as our initial point, and then we'll just go up a half point each time. That's the only difference here. Okay, so number one, our period is pi over b, and our b is 1, so we got period is pi over 1. Our phase shift, bx minus c, or sorry, c is pi halves. My b is 1, so I got pi halves over 1 is my phase shift. Pi halves, that'll be my starting point in this case. The half point is the period over 2. So our period is pi over 2. And like I say, with this, so make a note with the cotangent. I will start at my phase shift. And then I'll go up half point every time from there. And up a half point every time. I just keep going up a half point. So it's kind of like the sines and cosines and stuff, and the cosecants, secants, right? So I start at the phase shift. So phase shift is pi halves plus the half point pi halves. Pi halves plus pi halves is pi. Well, pi plus another pi halves is 3 pi halves. 3 pi halves plus another pi halves is 4 pi halves, or 2 pi. 4 pi halves plus another pi halves is 5 pi over 2. And this will be our vertical asymptote initially. You can plug them in to check that, make sure that they're undefined, and these will give me my intercepts. And let's go ahead and draw this thing. So at pi halves, get a vertical asymptote, pi 0, 3 pi halves, I've got another vertical asymptote, 2 pi 0, 5 pi halves, another vertical asymptote. And with the cotangent, remember the cotangent looks, you guys, like this. Looks, it's decreasing. It's decreasing. Okay, decreasing. Well, that negative in front is going to flip that around. So instead of this thing decreasing, it's going to increase. So it reflects it about the x-axis. Again, you can plug in a nice point like what's between 4 pi over 4 and 6 pi over 4? 5 pi over 4 would be a nice one to plug in. 5 pi over 4, and you'd get that 1 right there. Let's do a couple more of these cotangents here. So we get the period here is pi over b. So notice our b here is a half. So pi over a half, or 2 pi is our period. our phase shift, this is minus c, right? So it's like minus 0 inside that parentheses. C over b, so we got 0 over the half, so we got 0. The half point is the period, in this case 2 pi, but I cut the period in half. So the half point is pi. So we'll go ahead and start here. Since it's a cotangent, we'll start at our phase shift. And then we'll go up the half point each time. So 0 plus pi is pi. And then we'll go up another half point. Pi plus pi, 2 pi. And then 2 pi plus pi, we got 3 pi. 3 pi plus pi is 4 pi. And then we'll have 5 good spots. This first one will end up giving our vertical asymptote, right? If you were to plug in 0, cotangent of 1/2 times 0, that's the cotangent, cotangent of 0. Well, that's cosine of 0 over sine of 0. And the cosine of 0 is 1. The sine of 0 is 0. See how we can't do that? That's because we got a vertical asymptote. Can't divide by 0, right? So we got vertical asymptotes at those spots. And we'll plug in the pi as well. So we got cotangent of pi, and that'll end up being cosine of pi over sine. Sorry, I said that wrong. 1/2 pi, cotangent of pi halves. So we got cosine pi halves over sine pi halves. Well, the cosine pi halves is 0, sine pi halves is 1, so I get 0, 1, 0. Same thing with the 3 pi, that'll end up being cosine 3 pi halves over sine 3 pi halves, 0 over -1, which is 0. And then we'll go ahead and graph this. So we got x equaling 0. We got x equaling, and let's go to pi here. That'll give us 0. Then 2 pi is the next vertical asymptote. 3 pi is going to give us 0. 4 pi is our next vertical asymptote. Now this is the cotangent function, and so it is decreasing. And it has not been flipped over. You know, I got a positive 1 there, so it stays decreasing. A nice point to plug in would be like right between pi and 2 pi, like 3 pi over 2, and you would get -1, right? Cotangent of 1/2 times 3 pi over 2. See how we got cotangent of 3 pi over 4. So that's cosine of 3 pi over 4 over sine of 3 pi over 4. Well, the cosine of 3 pi over 4 is -√2 over 2. Sine is √2 over 2, so see how we got -1 there. So 3 pi halves spits out -1, and that's kind of a nice graph over a couple of periods on that. And let's do one more here. -2 cotangent. So that negative will flip that over. Of course, we got a phase shift here as well. Notice our c is -pi3. Let's start going to work on this. Our period is pi over b. B is 2. So we have pi over 2. Our phase shift, c over b. So we got -pi3 all over 2. So -pi6. Our half point is the period over 2. Well, our period is pi halves over 2. So we got pi4 is our half point. So we'll start, it's a cotangent, so we want to start at the phase shift, and then we'll go up pi4 from there. So -pi6 plus pi4, so -2 pi12 plus 3 pi12, that gives us the pi12, and then we'll go up another half point from there. So pi12 plus 3 pi12 is 4 pi12 or pi3. Pi3 plus another pi4, 7 pi12. And then I'll go up another half point from there. 7 pi12 plus 3 pi12 is 10 pi12, which is 5 pi6. And we could test these, but you're going to have vertical asymptotes there, they're going to be undefined, those spots. And the other ones are going to be intercepts at pi 12ths, 7 pi 12ths. Those will all be intercepts. Let's go ahead and graph this. So negative pi 6, we've got this vertical asymptote. Pi 12ths right there. And pi thirds. Another vertical asymptote. 7 pi 12ths hits 0. And 5 pi over 6 gives us another vertical asymptote. This is the negative cotangent, so instead of decreasing, instead of the decreasing, I flip that over because of the negative, and it's going to be increasing. You know, another a good point between, what's the halfway point? Let's go between pi 12ths and 4 pi 12ths. What's between pi 12ths and 4 pi 12ths? That'd be, follow this, pi, let me do this, 2 pi over 24, 4 pi over 12, 8 pi over 24. So right between them would be 5 pi over 24. That's what that point is. 5 pi over 24 would be smack dab between them. And if you plug that in, that's a cotangent, 2 times 5 pi over 24. Let's see what we get here. Oops, that's cotangent. So I got 5 pi over 12 plus 4 pi over 12. I got 9 pi over 12 negative 2 cotangent. 9 pi over 12 or 3 pi over 4. So I got negative 2 cotangent of 3 pi 4. So that's the cosine 3 pi 4, negative root 2 over 2 over sine of 3 pi over 4, which is positive root 2 over 2. So that would be a negative 2 times a negative 1, which is a positive 2. There's the point, 5 pi over 24, comma, positive 2. And hopefully that's enough to kind of get you started. Thanks so much for taking notes. We'll see you next time.